So in this exercise, we're gonna build and train a model to predict fashion amnesia dataset in two ways, using Keras API and creating custom model. These are the models we're gonna use throughout this exercise. So let's import these. So the first thing we need to do here is to load the data set, which we can do by calling fashion amnesia load data. We're going to split the data set into training and test data set. So after you download the data set, so we'll normalize the pixels and add another axis at the end by appending new axis for convolution layers, which we'll use later, and because it requires the channel dimension. And we do the same thing for test images. So these are the labels for fashion amnesia dataset. I just copied it down here. So let's print and plot the dataset to see what they look like. So for training dataset, we have 60,000 images of shape 28 by 28, and labels are given from 0 to 9. So if we plot these images with corresponding labels, we have these fashion items. So now they have data source, which lies in memory in this case. So we need to consume or iterate data points by wrapping it with TF dataset. So because it lies in memory, we just call from tensor slices. And as we talked in the slide, now we can fully use methods of TF dataset like shuffle and batch. So this number of data points will be shuffled out of the entire training data set, and we create a mini batch of size 32. And we basically do the same thing for test images, but except the shuffle method. So for this model, I will just use Keras sequential API to stack dense layers. So before we feed 2D images into dense layers, we need to flatten them by calling tf layers.flatten. And for the first layer of this sequential model, you need to specify the input shape. And then we just add fully connected layers like this. With softmax as the last activation, and the last output units will be 10, which is the number of classes in fashion MNIST dataset. And then we compile the model with these options. So we're going to use Atom Optimizer and sparse categorical cross entropy loss. So this loss is basically cross entropy loss you use when you're given labels in integers. And for metrics, we're gonna keep track of accuracy. Before we start feeding the model, so we're gonna run these code to load TensorBoard. So what we did here is just create a directory to save your TensorBoard logs. So with this, I will prepare a TensorBoard callback. By calling callbacks.tensorboard. And we just give it the directory to save the log files. And the frequency to log the training process. Now we train with the model, with the training data set. And we'll train the model for 10 epochs, while the TensorBoard will monitor the process. So if we start the training, so these are the training loss and accuracy. So you need to evaluate the model on test data sets. And you can do that by calling model.evaluate on these lines. And we got the test accuracy of 0.88. And you can also make a new prediction on test images by calling model.predict. And as you can see here, the model made a correct prediction as ankle-boot. And in order to plot the loss of TensorBoard, you just run this line. It will take a while, but you'll have this. So you can see the accuracy and loss over the epoch. And if you go into the graphs tab, you can see the entire computation graph. And if you change the tag here to chars, and you have one sequential model. And inside it, it has layers, the layers as we defined. So we just built a keras model and train it. So now we're gonna build a custom model and also custom training process. So for the custom model, I will inherit TensorFlow Keras model. And also use some convolution layer. So for convolution layer, you can use conv2d. So 32 is the number of output channels, and 3 will be filter size, and you use rel as activation. And after that, I'll just add dense layers again. So we need to flatten to the images. And now that we define the architecture of the model, we just implement the forward pass of the model inside the code. And you do this as in functional API. So you just chain all the layers. To get the output tensor. For the loss and optimizer, we'll use the same thing. And we want to keep track of mean loss and mean accuracy of each epoch. So we're gonna use TF Keras metrics. Now we build custom training and valuation graph. So for training step, we need to compute the gradient. So we're gonna cover our computation graph with gradient tape. And you feed your training data into your model to get the predictions, and you also compute the loss. And once you have the loss, the tensors for loss, you compute the gradients of the loss with respect to these model trainable variables. And to apply these gradients to update your model weights, you can call optimizer.apply gradients, and you give the result of zipping gradients and the variables. And because we want to keep the training loss and accuracy over one epoch, we will also run these metrics. And we are going to do basically the same thing, but in the test step, we don't need to compute the gradient. we will remove the lines for gradient tape and other lines to compute gradients. So now the last thing we need to build is a training loop. We're going to train the model for 3 epochs, and each epoch we're going to consume the training images from the training data sets. And for each batch, we'll update our model. And at the end of each epoch, so we're going to evaluate our model with validate our model with test data sets. And I will also add some more logging functions. And because we track of loss and accuracy over each epoch, we need to reset the metrics to set them back to 0. So here is okay. So training has finished. We have these test loss and test accuracy. So now you may want to save our model. So let's use tf.savedModel.save to store the model and its weights. Now, of course, load it back by calling load. And because we stored the model using saved model format, we don't have to draw a graph again, but we can just make a new prediction on a new data points. And here you can see the model made a correct prediction. And we just built and finished training the custom model. So that's all for the exercise. Thanks for watching.